Welcome to GKey Solutions Private Limited.
SQL Server Database, Real-Time Interview Questions and Answers. Question number 56. How to work with large datasets efficiently in SQL Server Database. In this session, we are going to discuss about how to work with large datasets efficiently in SQL Server Database. When working with millions of rows, poor query design can crash performance. Here are key strategies with examples you can see in this video. First, use proper indexing. Indexes help SQL Server find rows without scanning the entire table. For example, if you are not using any indexes, will cause a table scan. It will scan all the data in the table. To fix this, what we have to do, we can go and create a non-clustered index on a particular column like product in the sales table. In this way, you can get the performance for the query. And coming to the next point, that is avoid select star. Fetching unnecessary columns increases IO and network load. Here, if you want to select only particular columns, don't go for select star. You can just go for select particular columns and you can use the where condition. Then it is going to give you the better performance. In this way, we can avoid select star and we can use select what are the columns required and from the table, and you can use a where class as well. Coming to the third point, that is write searchable queries. Search is equal to search argument plus queries that let SQL Server use indexes efficiently. If there is no searchable index, won't be used. Select star from sales where year of sale data is equal to 2024. Index, if index can be used, select star from sales where sale date is greater than or is equal to some date and sale date is less than or equal to some date. In this way, index can be used on a searchable queries. By using a searchable queries, we can get the performance here. And coming to the fourth point, that filter early and minimize rows. Always use where top join filters early to reduce the result set size. If there is no filter, processes entire table. That means if there is no filter on a particular query, it processes entire table and it will take time to fetch the data. Whereas if you have some filter like this, for example, where sale date is greater than equal to some date, then it will directly go to this where condition, it will fetch this data, and based on that data, it will select the columns whatever we require. In these scenarios, we should have early, like filter early and minimize rows. Then you can get the query output faster compared to the without using filters. And coming to the next point, that is fifth one, use batching for very large operations. When deleting and updating millions of rows, do it in chunks. Delete in a batch of 10,000 rows means we can use while 1 is equal to 1 begin delete top 10,000 from sales where sale date is less than or equal to some date, whatever mentioned here. If at the rate row count is equal to 0, break. That means at the rate row count 0 means we have to break this thing, and we are ending this begin and end for the while loop. This avoids locking the entire table for a long time. In this way, we can avoid the locking the table for entire time. It will do the deleting process based on the chunks, that is 10,000 rows we are deleting for a batch. And coming to the sixth point, check execution plan. See, execution plan tells us if SQL Server is doing table scan or table window scan or window 6, something like that. If there is a table scan, it would be very bad. That means it is going to scan all the rows in the table. Then we can identify the missing indexes and we can create the indexes on them. Then it will convert it to the index scan. Then you will get the performance for the query. And if there are any expensive operations, then we have to identify them in the execution plan based on the time of the execution, how much time it has taken, something like that. By using Control M in SSMS before running the query, check if you get index seek and not scan or something. All these things you can check over there, and what are the different operations and how much time it is taking. Based on that execution plan, we can take decisions, and we can tune the query, and then we can use it. In this way, we have to check the execution plans before tuning the SQL Server queries. Coming to the seventh point, use statistics IO runtime. Measure performance impact after changes. For example, if you set statistics IO time on, run your query, set statistics IO time off. Look for a logical reads, that is lower is better. In this way, you are going to see the logical, what are the different reads happen, how much time it took, what is the CPU time and elapsed time. All these things you can see in the statistics IO time. If you set these things in the query, you can visualize these things in the query after execution, and based on those results you can tune your query, and after tuning also you can set this, and you can identify the difference between the query execution times. In this way, the statistics IO time will be useful to tune the query, to identify what are the different blocks happens in the query running. Avoid cursors and row by row processing. Instead, we can use set based operations. These are faster. See, cursors looping through rows. Each row, if you create any cursor on a particular thing, it will just loop through every row by row. It is going to loop through. Instead, single update for all rows. We can use a single update for all rows. Update sales set price is equal to price into 1.0 something, where product is equal to product dot. In this way, we can use a single update instead of using cursors. And coming to the ninth point, that is consider partitioning for very large tables. For billions of rows, use table partition to divide the data by date or a region or improve the query performance. Here are the final steps, how the kind of a tips and how they are going to help you to get the performance. If you use indexes, it speeds up row lookups, and if you select only needed columns, reduces IO and network load. If you write surgable where class, allows index seek. Filter early, that means processes fewer rows. Batch large deletes or updates, avoids locking entire table. Analyze execution plan, it will gives you and finds the bottlenecks in the query. Measure with statistics IO, that means quantifies performance. And coming to the use set based queries, avoids row by row overhead, that is cursors. If you use cursors, avoid them and use update instead. Partition very large tables, it improves the manageability and query speed. In this way, we are going to get a large data sets efficiently in SQL Server. In this way, by using all these points if required for the query, then we can work with large data sets efficiently in SQL Server database. Large data sets in the sense the records are like millions and billions, you can see. While processing or while querying any kind of a thing, like if you write any complex query on that, you have to tune the query better. Why? Because if it is working on the billions of records, to get the data based on a particular requirement, it will take more time. If you use any functions, calculations, all these things you have to take care, and you have to look in statistics and execution plans, how much time it is taking, and what are the different roadblocks, and what are the different alternate solutions we can apply on your query, and you can better tune your query and you can get the performance. In such a way, while working with a large data sets, as we discussed, there are different points. Based on your requirement, you can implement them and you can get the performance. Thank you. Stay connected with GKey IT solutions on all your favorite platforms. Follow us on YouTube, LinkedIn, Instagram, and Facebook. Don't forget to like, share, and subscribe to our YouTube channel, and press the bell icon to stay updated with all our latest content. Join the GKey community and grow your IT career with us.